Alright, time for another DraftPhysics.com video presentation. So the guy Technologic, who's called Benjamin CD something or other, Drake. Anyway, sunglasses. We'll call him sunglasses. Anyway, okay, so he's made a video response. Might as well play it. I listened to the first couple of seconds. It's, he's just ragging, so it ought to be entertaining.
Okay. So in your video, you had said that, why don't I address your scenario? Why don't I address your scenario? It's been like, what, 2 days? If you had read my whole comment, you might have spared yourself a lot of frustration, because in regards to the scenario that you had did just...
Yeah, I did read your whole comment, so I mean, it's kind of, pointless. Yeah, you made some reference to some video you're going to make, maybe. What was I supposed to think the video would have in it except mathematical crap? I mean, the same crap I've seen for 2 years. Doesn't mean anything. But anyway, go ahead.
For me, in my reply to that video, I said, towards the end, maybe I'll record my reasoning at some point and you can tell me what you think I did wrong.
Yeah, well, whatever. My point is I wanted Physics Michael to respond to some of these arguments, okay? And the point is that you just let him right off the hook. You had him, okay? You had him paying attention to your critiques and your points in terms of saying, well, this doesn't add up and relativity doesn't quite fit and blah, blah, blah. And so you had a perfect opportunity to throw in there, well, isn't it really 9.8 meters per 1 second, not per seconds squared?
I see you're like a funhouse mirror. Like, everything gets distorted.
Yeah, whatever. What did I distort, liar? Okay, pig face, moron, creepoid, fuckhead. What's distorted, fuckhead? Could you quote a distortion I've made, fuckhead? They're the ones lying about what Newton said. All right, again, you don't pay any attention to these arguments at all, do you? I mean, really, seriously, do you really think it's fair to Isaac Newton to say that his physics leads to something he directly opposes? He overtly, right in the text of the second law, he says, twice the velocity, twice the force. 3 times the velocity, 3 times the force. I mean, he says it directly, okay? It is not 1/2 mv squared physics. It can't be converted into 1/2 mv squared physics. It's an objection to it. And you liars, okay, keep defending this perversion. And you call me the house of mirrors and cheats and lies when that's all you fuckers have.
Say you find me tedious? Well, I assure you the feeling is mutual. I find your stop-and-go, pinball style of analysis excruciatingly tedious, especially since you can't go from one...
Yeah, pinball machines are so damn tedious. That's why they're, like, almost addictive. It's because they're tedious. Oh, God. Your analogies don't even fit.
...sentence to the next, without mischaracterizing me, my
yeah, no, that's all a lie, okay? Your comments are quite public, they're quite obvious, there was no mischaracterization. There's clearly nothing that Physics Michael had to say to your comment but thank you. That's it. He was done. You gave him every reason just to walk away.
Context, the things I said, and so on. You leave no pebble unperturbed as far as that goes. Every possible thing ends up out of place. And, having seen how you operate, I'm not even going to waste any more of my time.
Yeah, good. Don't waste any more of your time. I'll block you, make it easier for you, okay? And, yeah, I just will ignore your existence, okay? Because, yes, you're a useless, douchey, wishy-washy punk of fucking talk out of both sides of your motherfucking little weaselly face jackass. So, yeah, fuck you.
I'm trying to make myself understood as far as that goes, because it's very...
Yeah, there's nothing to make understood. You just keep babbling backward and forward and backward and forward, and you don't say anything.
Evident. That's going to be wasted, futile effort. So instead, I'm just going to go ahead and record my thoughts on your scenario, because I'm curious how you'd respond.
Yeah, I'm curious how much it won't have anything to do with a fucking thing I actually wrote on the fucking board. Right? So for 2 years I say, could you please draw a lever? Or if you're going to play my clips, I've made them now 5 minutes long, and not one of you fuckers can actually deal with my actual argument and respond to the actual argument I'm making. And then you call me the perverters, when you're the ones who can't play the actual fucking argument. Oh, amazing. I'm playing your video, little weaselly cunt. You're not playing mine, weaselly cunt. Oh, these people are such pieces of shit. I mean, the duplicity of these fuckers.
I'm going to modify the scenario somewhat, though. So, you know,
See, I'm going to modify the scenario. Fuck you. Modify what? It's fucking gravity, for fuck's sake. It doesn't need modifying. You drop it from 1 unit of distance, you drop it from 4 units of distance. But it fucking needs to be modified, fucker. Oh, god damn. Yeah, just for clarity. So understand. Look, here's the same drawing. It's still here. Look, okay. So you're flying by something that has gravity. I'll redraw it over here. Okay, here's something with gravity. You're flying by. Here's a fixed distance. What's going to decide whether you crash or you go straight? Oh, that's right. Exactly. How fast you go. What does how fast you mean? It means how much pressure is going to be applied to you. What decides how much pressure? How much time. Just like a suntan. No difference. The longer you're in the sun, the more burned you get. The less you're in the sun, the less burned you get. That's exactly how gravity works. This proves it. You don't need any more explanation than this fucking little simple drawing. The only thing it proves, it's a time-dependent force. The distance is irrelevant. All that matters is how fast you go from point A to point B. That decides exactly how much force is pushing you this way. So damn simple. Then you need to restate it in some other form. Yeah, right. You're a fair cop. Oh, shit.
question about weight, I will save for a part 2. I want to modify your scenario somewhat because I want to gauge your response. I want to see what you understand, and your response will, I think, be an ultimate indicator to me whether further dialogue with you is just going to be a waste of time. So let's suppose we're looking at a scenario where an object of mass m is subject to the force of gravity. Not actual gravity. We're doing this horizontally. So
oh yeah. So what sense does this make? We're doing horizontal gravity. Blah 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 blah.
An equivalent force of gravity, and over
the fine.
course of a second, it will have moved some distance. So it would be 4.9 meters, and by the time it reached its final position, it'd be going.
That's after 1 second, and it's already going 9.8 meters per second.
9.8 meters per second. And in another scenario where we have the same mass, if it's in gravity for 2 seconds, it will have traveled 4 times the distance, so that would be something way over here would be its starting point, and this would be 19.6 meters, and by the time it reached its final position, it would be going 19.6 meters per second. So, just for completeness, I know you want to know what happens if there's a wall or ground there. What would the force of impact be? I think that's what you're asking when you say what's the weight, is what's the force of impact, and since the velocity here is twice as much as the velocity in the first scenario, it seems pretty straightforward that.
No, the point is how are you collecting the force? It's clearly a time-dependent force, okay? So if you have some tangential velocity and you're flying through the gravity, the bending will tell you exactly how much force you're being affected by. You're obviously only going to get bent twice as much for being in the gravity twice as long. You've clearly only collected twice the force. Oh, whatever. Too silly.
It would be twice the force of impact. Now, I want to modify this by saying, what if we get rid of the wall that's there, and we have all the space on the right still available to us? What if, once these velocities had been reached, we applied the same force of gravity?
Oh, so there's just no point, really, because then you're really proving the case, because then there's 2 things flying through space, and one of them's going twice as fast. It's going to cover twice the distance. So your distance argument's in the garbage now, okay? You can't use distance anymore because distance is going to be it's always going to be twice the distance. The thing going twice as fast will always be twice as far away.
Gravity, but in the opposite direction. Then how far would the objects go before coming to a halt? I would argue that since it's this exact same force, same magnitude.
Yeah, duh. Exactly. That's right. You shoot it into gravity, it goes 4 times higher. If it was a spring they landed on and it was 100% conservative, they'd bounce right back to the point they started. So what?
Just opposite direction, that rather than accelerating from left to right, they would begin to decelerate from left to right. And again, since the force is the same magnitude, they're going to cover the same distance. So this object.
Yeah, and they're going to slow down exactly the same way. This 4.9 thing is going to happen right here at the end. So the thing going fast is going to start slowing down, and it's not going to be going half its speed until it goes 3/4 of the travel. So when it gets 3/4 of the way, then it'll start going exactly the same speed as the other one went for the whole trip.
would come out to 4.9 meters before coming to a halt, and this one would go to 19.6 meters before coming to a halt. Very straightforward. I don't think at any point so far I've said 1 + 1 = 4. This is just a very straightforward
yeah, because you haven't said anything about kinetic energy. You've just described perfectly how gravity functions, and that's it. You haven't said anything yet that's challenging anything Newton said,
application
or
of
Galileo, or Descartes.
principles on the left side to the right, except in reverse, sort of. So, the next question I would pose is, what would happen if I were to double the force in that direction for both scenarios? Where would the object come to a halt then?
Well, what do you mean double the force in both scenarios? So instead of 9.8 meters per second, it's 19.6 meters per second. So then you're just going to do the same exact thing with this higher velocity. It's still just 2 units, so it's still just 40, for one and 20 for the other. 10.
Well, since you're doubling the force, I would argue that you would halve the distance. Same factor, right? We're not saying 1 + 1 is 4. So here it would come to a halt after 2.45 meters, and here it would come to a halt in the middle there, which would be 9.8 meters.
Well, then it wouldn't be a second, then, would it? You're not doing it per seconds anymore. You've changed the time units to do that.
Again, very straightforward. So, having established that whatever factor that you increase the force by, you divide the distance by, well, suppose I ask the question, what force would we have to apply to the object in the second scenario for the object to come to a halt about there, so that it lines up with this guy? In other words, what force would I have to apply in the second scenario for the object to come to a halt after 4.9 meters? Well, since 4.9 is a quarter of 19.6, I would...
That's not exactly. So you just broke the rule, right? Because we know that that's not where it goes, 4.9. It goes 4.9 way down here. That last little bit of the travel is when it does that part. Okay, the 1 second to do 4.9. This will be 1 second, this little tiny bit here. The other 3/4 will be 1 second. So you're ignoring that and pretending it's a halfway thing when it's not a halfway thing. So that's the simple flaw in your reasoning.
Argue that the force you have to apply would be 4 times the force of gravity. 4 times the force of gravity, as you did when you were going half the velocity, in order to come to a halt at the same distance. Now you
No, all you have to do is cut the velocity in half, so it's not 4 times at all. So, bullshit.
might ask, who gives a shit about this? Why does this matter? Well, I suppose it might matter if, let's say, this wall here is the surface of Mars, or let's say that it is the docking port of the International Space Station. What would happen if, during one of our trips, let's say our protocol is to begin applying the brakes 4.9 meters above the surface. If our protocol was we have to do it within that distance. And during our previous trip, we applied a given force to safely come to a halt when our velocity was 9.8 meters per second. Wouldn't it matter that if we want to achieve the same thing, come to a safe halt after 4.9 meters, going 19.6 meters per second, we'd have to apply 4 times the force? Or do you think that it would be 2 times the force?
I'm sitting here saying, why am I doing this? Because again, this number isn't right. So it's not 4 times the force. So you've divided again the 4 units of distance into equal units when they're not equal. Alright, look, I should be able to say this clearer. Where he's saying it's 4 times the force to go half the speed, of course it's not. Because that's exactly what the other object's doing with only 1 unit of velocity. It's going 9.8. It's not going 4.9. It's going 9.8 meters per second. All you're doing is halving the velocity to go 4.9 meters in 1 second. So it's just wrong to say you needed 4 times the force to go half the speed. You don't need 4 times the force to go half the speed. So anyway, continuing.
Because if you do 2 times the force, you're only going to have the distance that it would travel, which means you're going to end up crashing.
So again, you just put that line right in the middle, didn't he? And that's not how gravity works. You're not going half the speed, okay, in the middle. You're going half the speed right here. You're going 9.8 here, and then you do this whole section, okay, before you get to 19.6. So it's 1 unit of distance to go 9.8, and then 3 units of distance to increase it another 9.8. You're only getting 9.8 for 3 times this time in gravity. 3 times the distance in the gravity is only getting you 9.8. So again, we've already talked about this halfway thing. I've mentioned it in numerous videos, and here he just does it. He just says gravity, you're going half the speed at half the distance. No, you're not going half the speed at half the distance. You're going half the speed after 1/4 of the distance.
So far, have I said 1 + 1 = 4?
Yeah, you have. So far, you blew it. Yes, you already fucked it up.
Have, please tell me where. Because, as far as I can see, I'm just applying the same principles that we saw on the left side to the right. Except now I'm dealing with factors, right?
Yeah, you're not dealing with reality, though, because it's not how gravity works. Doesn't work that way.
I'm dividing on that. You agreed that the object traveled 4 times as far on the left side. Why would it be different on the right side? And if we multiply or divide the force, why wouldn't we do the inverse with the distance that it travels? Right? So that's where I see that 4 coming up. Shoot.
But you can see it all you want. We already know what half the speed does. Half the speed goes 1/4 of the distance. That's all it does. That's what half the velocity does. It goes 1/4 of the distance. Half the velocity doesn't go half the distance.
So the question I pose to you is this real? Am I describing something real here? Does it really take 4 times?
No, you're not. You're just evading the simple argument, okay? The simple argument is here's a planet, here's a distance. I'm going to travel through that distance. How much am I going to get bent? Based on how long I'm in the gravity, right? That's all that's going to decide. The more time I spend in the gravity, the more I get bent. The less time I spend in the gravity, the less I get bent. It's completely a time-dependent force. There's nothing else that affects how much you're affected by gravity except how much time you're free falling in it. Period. End of the subject.
The force. And is this something that an astrophysicist would think is important? Or is this just some silly, fanciful...
Yeah, it's nonsense. It's not realistic, and it's not connected to reality. And your little line right here at the halfway point is the proof of how you didn't pay any attention, okay, to the fact that when it's falling, it's going half the speed after only 1/4 of the distance. It's going half of its final speed after 1/4 of the distance. And that always ends up being true. So after 1/4 of the 4.9, it's probably the same actual truth. Is that after 1/4, he's already going half the speed that it's going to get to when it gets to the 9.8. That's the way gravity works. That's the way the acceleration in gravity works. You go half the speed after you travel just 1/4 of the distance, your final distance.
Daydream or something. So answer my questions. Tell me what you think of my reasoning so far, and then we'll see if it's worth following up to discuss what happens if it were to collide with the wall or the ground or whatever. I think that
or the ground or whatever. Yes, we're just basically you're basically the only thing you have to explain is how does twice the velocity mean to you? That somehow you need 4 times the energy to do twice the velocity. Why would there be any necessity? And to go 3 times as fast, why would I need 9 times? And to go, 4 times as fast, why would I need 16 times the force? Except for your formula, what suggests that to be the truth? What physical fact in the universe, what event that takes place implies it even? Where does something even imply it? All right.
should do it.
So, whatever.
Okay.
Okay. So let's see if there's something else. I guess I could throw in something else. There was some video I saw that was just so bad. I didn't see it, I actually listened to it. So maybe we'll just rag on that because it was such tripe. So, it's just so, yeah. Alright, I'm back. Alright, so I listened to this video. I didn't see this guy. And then, I saw the Ask a Spaceman. He's not a spaceman. I mean, he's not an astronaut or anything like that. So this is just such a lie. And clearly he's, some sort of gay kind of person. So it'll just look like gay bashing or something. But I mean, I had a whole thing, a whole shtick I was going to do. Just because this video is such a piece of trivial shit. So let me play some of it. Alright. I don't mean any offense in mocking it. And I had a whole scenario set up, because this is showing science to be just baby talk. It's a fable, a little silly story. And it's like some religious person saying, in the old days, people used to follow Jesus and wait for him to take a holy shit. And then they would shove the holy shit in their ears, and then everything would be clear, and they could understand everything because they had the holy shit in their ears, that kind of thing. And I just had a whole, theatric production I was going to do, but yes, no, there's no point because it'll just be called gay bashing or something.
Tell you 3 things about magnetic fields that I'm guessing, I'm just throwing this out here, that you probably didn't know. And these are like 3 surprising tricks of magnetic fields.
And it's absolute nonsense. It has nothing to do with magnets. It has to do with black holes and bullshit. I mean, it's just amazing that he puts the word magnetism in here, and it has nothing to do with magnetism.
Trick number 1. How can a black hole, black holes, how can a black hole have a magnetic field? Black holes, the very definition of a black hole is that nothing can come out, not even light, which is electromagnetic.
The holy shit. Man, the holy shit can get out of the black hole. I mean, it's just such a stupid argument. Yeah, the gravity can't even get out of the black hole. I mean, it's all just such a pile of nonsense. They have absolutely no real interaction with anything called a black hole. They have nothing. It's all theoretical shit. Okay? And the only way you can understand any of this shit is to fill your brain full of shit.
Radiation. So how can a black hole have a magnetic field if nothing can come out? Well, here's the thing. This is the exact same question as asking how can a black hole have mass? How can a black hole emanate the force of gravity?
So again, it's like as if there's absolutely no reason for anybody to ever think that the gravity could be going the way you actually fall, like it's coming from the outside in. Oh, that would be a silly conclusion. That we're being pushed into the earth? I mean, that would be crazy, right? Push? That's impossible. How could you fucking push anything? Pushing is impossible. Pulling is so natural. It's such a natural thing that happens all over the place. Everything's always pulling on other things all the time.
If nothing can come out of the black hole, how can a black hole emanate the force of magnetism if nothing can come out of the black hole? Here's the thing.
Here's the thing. So we all know that whatever it's emanating, okay, it's not like radiation. It's not coming from the magnet. I mean, even a dope could figure this out, right? whatever it's doing, somehow it's got an infinite supply of it. So wouldn't the logical thing to be to say the magnet is really just reflecting something that's already hitting it? I think that would be the smart thing to say. It's not providing the force, it's changing the force.
You're in the vicinity of a black hole and you're feeling its mass and you're feeling its magnetic field. You're not feeling the mass or magnetic field of the black hole itself. You're feeling the mass and the magnetic field of the ghost of its parent star.
Oh, look at that. The ghost of its parent star. Because everything's a hologram in the, the holy shit aura.
Remember what happens when you fall into a black hole?
just remember, like anybody's ever done anything like this, like they have had any interaction with a black hole at all, and they talk as if I just did it yesterday. Yeah, it's really cool. Alright, enough. I'll just let it go. It's just, this world is too ridiculous. It's just, ask a spaceman. Spaced out man. Fuck. Alright, anyway. So I think that's it. I don't think there's anything else news, so I will move along and wait to see where the big lever experiment shows up. Yeah.